So let's talk brain damage. Ooh, not a very pleasant topic, is it? It seems to be getting a lot of buzz recently with media coverage and the recent movie that came out, Concussion. There's a focus on chronic traumatic encephalopathy, or CTE. Now, CTE is broadly defined as a degenerative neurological disorder that's often associated with repeated head trauma. So the populations at risk include military veterans exposed to blast damage, victims of domestic violence, and of course, athletes who participate in contact sports, which is why we're worried. We're worried about kids getting concussions, and we're worried about them playing hockey and football. Now, I'm working with Drs. Amy Neal and Jessica Richardson here at UNM in conjunction with the Cleveland Clinic out of Las Vegas, who are conducting the Professional Fighters Brain Health Study. And this is a long project whose aims are to study the brains of professional boxers and mixed martial artists to see if they can compound more data about CTE, including a way to diagnose it before death, because right now it can only be diagnosed on autopsy. So the focus in our lab is speech characteristics. All of the participants read the same passage once a year, and we look at specific speech markers that we can calculate from analyzing this reading passage. So we calculate speech rate, which is how fast people talk. We look at pauses, how long they are, and also if they're put in places where we expect them. We also look for disfluencies, which are interruptions of speech. Disfluencies can appear like the speech of people who stutter, but they can also be excessive repetitions or revisions of words and phrases. And once we put all the data together, we can look at it two different ways. We can compare it to a group of healthy controls, which is people who don't have a history of head trauma, or we can compare it to the fighters themselves over time. We can track how their speech changes every year, because we also know how many bouts they've had. We know how many times they've been knocked out. And hopefully we can create a standard set of measurements to say, okay, once you hit the standard, you're either exhibiting symptoms of the disease or you're at very high risk for developing it. But we can just do an MRI, right? Why would we bother with all of this? It turns out that scanning for CTE is very difficult. The damage is so small that even with the instruments we have now, we can't see it. It's easier to look for symptoms of the disease rather than the disease itself, and one of the symptoms seems to be changes in the way people speak. So if we can standardize the speech characteristics for people with CTE, we can use it to diagnose it in the living. We can diagnose it early. We can help prevent brain damage. Thank you.
Thank you, Sofiya. So you today have been our third person from Speech and Hearing Sciences, and we had a lot of people from Speech and Hearing Sciences participate in the preliminary LoboBITES. So thank you to the faculty that have encouraged this. But I want to just ask you, what encouraged speech and hearing sciences students to participate in this opportunity?
I think we have a very robust department, and we have amazing researchers and amazing academics, and it's really the credit goes to them for getting us involved in their research.
Great. And tell us where you're from, Sofiya.
So originally from Russia, also some Michigan time, and now here.
Were you told you would have any problems learning English?
No, but I was really young. I was lucky. I was very young when I came here, so.
Great. Thank you so much, Sofiya.
Thank you.